Good morning, guys. Today we are going to talk about the triangle inequality theorem. Pretty fun and pretty easy. So if you take 3 straws of lengths 8, 5, and 1 and try to make a triangle with them, you'll find that it's not possible. Okay, and if you're in person, I would be doing an activity similar with it, to this with you. So the triangle inequality theorem says that the sum of the lengths of any two sides of a triangle must be greater than the lengths of the third side. So if you're looking here at this triangle, A plus B should be greater than C, B plus C should be greater than A plus C should be greater than B. So if I'm looking at these, I have to figure out, is it possible to form a triangle with these given lengths? I always just take the smaller two, add them together, and see if they are greater than the third side. Okay, so I'm going to add together 3 and 4. They're the two smaller ones. 3 and 4 adds to be 7. So since 7 is greater than 6, this would form a triangle. So I would say yes. Their main question here is, does it form a triangle? This one here, I have 8 and 8. That combines to be 16. 16 is greater than 8. So yes, this would form a triangle. Here I have 4 and 8. I add those together to get 12. 12 is not greater than 16. So this would not form a triangle. If I look here, I have 6, 9, and 15. If I add 6 and 9, that gives me 15. 15 is not greater than 15. It's equal, but it's not greater. So this would not form a triangle. 2 and 4 add to be 6. 6 is greater than 5. So this would form a triangle. 1.5 and 2.5 add to be 4, which is greater than 3. So this would form a triangle. Okay, so I just paused my video for a second to just show you guys. I wanted to open up the screen, an example. So the first example we just did on the notes that didn't work was 4, 8, and 16. So if I do one side as 16, one side as 4, and one side as 8. I can't possibly make these triangle legs meet. Okay, see, they're never going to meet each other no matter how I move these. However, if I do an example like 8, and 8, okay, I can make this into a triangle. I can make these two dots meet each other. Okay, you guys see kind of how this works. So 2 of the sides cannot add to be a smaller or equal number of the third side. Okay, so you guys can play around with this at home if you want. I'm going to post the link to it. In person, the kids will be playing around with it in school. So if you want to play around with this, then check it out. But if you get the gist of it, you don't really need to. Okay, back to the notes over here. Find the range. The last thing we're learning today. This bottom piece is proofs. We do not do proofs this year, as you guys are very lucky. But as I've told you already, we've decided not to do proofs this year, so you can ignore the bottom part. But the last piece of the triangle inequality is finding the range for the third side. If you are only given 2 sides, you have to be able to tell me, okay, Miss Sweeney, this third side could be between 5 and 10. Okay, so you have to be able to give me that. There are a few steps to this, which I'm going to flip this page over and write them on the back, just so I have some room. But the simple steps to this is first add the 2 sides that you have to find your maximum, your max. And then you want to subtract the 2 sides to find your minimum. And always when you're subtracting, do the larger number minus the smaller number. Sometimes we get confused with that and we end up getting negatives. Okay, for the minimum, we're always going to do that larger number minus the smaller number. And then last part is just writing our answer. Our answer is going to be written as an inequality, so you should have your minimum value is less than x is less than your maximum value. And then this is your final answer. So it should be written as an inequality. Basically, this is called a between statement. So you're just saying that this number, this random number x that we're trying to find, so this third side, should be between this number and this number. It should be between your minimum and your maximum. But notice there's no underlines here. So it can't be equal to your minimum or maximum. It has to be just between it. So if I said it has to be between 5 and 10, it can't be 5 or 10. It could be 6, 7, 8, 9. It can't be 5 or 10. Okay, so let's do an example of that together. So if I have sides 1 and 6, first to find the maximum, I'm going to add those together. So 6 plus 1 is 7. So my maximum is 7. For my minimum, I'm going to subtract those. So 6 minus 1 is 5. So my minimum is 5, my maximum is 7. So I'm going to write my statement, 5 is less than, x is less than 7. So my third side could be between 5 and 7. Okay. Pretty simple. You can kind of tell here the answer is probably going to be 6, but you have to remember there are decimals. Could be 5.5. Okay, that could work. So you have to remember that there are more than just whole numbers. So it could be 5.5, 5.75. Any number between 5 and 7 could work. But we can't say 5 or 7. All right. Another example here, I have 12 and 18. So to find my max, I'm going to add those. 12 and 18 gives me 30. That's my maximum. My minimum, I'm going to subtract them. 18 minus 12 gives me 6, and that's my minimum. So now my minimum is less than x is less than my maximum. So any number between 6 and 30 would work as my third side. So I could use 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. Or decimals, but I could not use 6 or 30. All right, hopefully this helps, guys. If you have any questions, please reach out. I hope you have a wonderful day and a wonderful weekend.